देखो देखो एप्पल और केला भी लिखा है यार, दिख नहीं रहा ये कौन सा जो कौन आया यार अभी क्या? अबे ये क्यों दी तो खत्म हो गया पागल लड़के भगा उसको
मेरा भी शक्ल आ गया 50 शक्ल अच्छा लग रहा है एक केला खा रहे भैया
अरे यार तुम जाएंगे यहाँ से
केला के बदले गो खा लीजिए
कॉल मत कर भाई कॉल मत कर कॉल मत कर मैं साले कॉल मत कर काट ना कॉल बाहर है किसी से अच्छा प्राची लेके भाई बीच में सही बता रहे हैं 80 का चार्जर भी दे दे ए ले ले बस सेटअप छोटी लौटे कब जाएगी लौटे जुलाई ना जुलाई उस दिन 2 जुलाई का बाहर में तो चार्ज नहीं है बाहर में क्या कर रहे हो बाहर अब बाहर में तो मजा आएगा अबे दे देंगे तुमको फिर बाहर में नहीं यार अभी जाना है अभी ट्रैवल कर रहा है मोबाइल चार्ज दे तुम समझ रहा टिकट हम बोलेंगे करवाना है क्या कर रहा है क्या बोला सीट है पे सीट अब नहीं है सीट नहीं है वो बीसी कौन सा बी है मतलब वो जो ये वो नहीं है वो ये है वो चार्ज कहाँ पे चार्जिंग तो चार्जर उसमें नहीं है यार चार्जर क्या है चार्जर
What is this? What is this behavior rule? What is this behavior? Come on, come on, come on, come on, come on. Oh yeah. Come on, bro, come on. Connecting.
तो इस वीडियो में हम लोग काफ़ी इंटरेस्टिंग सा कुछ देखने वाले हैं दैट इज़ अबाउट जी सैप एंड आप कह सकते हो GLSL के साथ कुछ इंटरेस्टिंग सा बनाएंगे एंड मैं इस वीडियो में आपके पास सिर्फ एक चीज़ बताने आया हूँ सबसे पहले कि डेफिनेटली ये पूरा सफ़र बहुत ज़्यादा कठिन है ठीक है इट्स गोना बी एक्सट्रीमली डिफिकल्ट वाई बिकॉज GLSL इज़ अ कम्प्लीटली डिफरेंट लैंग्वेज फर्स्ट ऑफ ऑल ठीक है आपको वहाँ पे कई सारी मैथमेटिकल इक्वेशंस लिखनी पड़ती हैं आपको साइन कॉस ए टैन एंड अ लॉट ऑफ कैलकुलेशंस मैथ्स डॉट पाई वैल्यूज को डिवाइड करना डिग्रीज एंड रेडियंस में काम करना देयर इज अ लॉट इट्स अ कंप्लीटली डिफरेंट लैंग्वेज आई बिलीव इट्स समथिंग जो इट विल आस्क अ लॉट फ्रॉम यू ठीक है तो ऐसा समझो इस पूरे प्रोजेक्ट को इस नज़रिए से देखो कि जितना समझ आ जाए उतना ले लो ठीक है और जो नहीं समझ आ रहा है उसको नकल कर लो नकल समझते हो देख के लिख लो एंड पहली प्रायोरिटी ये रखो कि प्रोजेक्ट को कंप्लीट करो अगर आप मुझे जानते पहचानते हो तो आपको पता होगा मेरी आदत है चीज़ों को काफ़ी डिटेल में समझाने की राइट एंड आई मेक श्योर कि मैं आपको जितना डिटेल में चीज़ों के मैं रखिए और जो समझ ना आए कोई बात नहीं ट्राई टू कंप्लीट द प्रोजेक्ट लोगों का आप कह सकते हैं ट्रेलर में ही देखने को मिलेगा राइट मॉड्यूलर स्ट्रक्चर क्यों ले रहे हैं हम लोग एंड चीज़ें कैसे हो रही हैं राइट 3J शुरू करेंगे क्लासेस के साथ जो कि फंडामेंटल्स हैं अगर आप ये नहीं सीख पाओगे तो प्रोबेबली यू विल नॉट बी एबल
The most visually mind-blowing websites in the world all seem to follow a similar pattern. They use 3D animations that bring the content to life when the page is scrolled. A website like mav.farm doesn't have a scroll bar, but instead animates a whole 3D world as you scroll through the page. This may look impossibly difficult, but in today's video, you'll learn how to create your own 3D animations with JavaScript using Three.js. By the end of this video, you will have built a personal portfolio website that's so impressive it's guaranteed to get you a job or your money back. And you might be shocked at how easy it really is when you understand a few concepts related to cameras, lighting, and geometry. This tutorial is beginner friendly, and I'll assume you're brand new to Three.js and 3D graphics in general. What we'll build today is a website that uses CSS Grid for its main content and has a 3D animated background that changes the camera perspective as the user scrolls down. Looking closer, we have an avatar image that is actually a 3D cube that rotates as we scroll down. Then we have a big 3D ring that rotates continuously. You'll also notice a bunch of 3D stars in the background that change their position as the camera moves. And at the bottom, we have a rotating moon animation. It doesn't look perfect, but it's about as realistic as the official moon landings. The inspiration for this video came from atelier.net, which is a great example of an amazing website that uses both CSS Grid and Three.js. But what is Three.js exactly? Well, basically, it's just a library for drawing 3D graphics in the browser with JavaScript. You have a bunch of geometries or shapes that get styled with textures, which might be done with math or just a regular raster image. A scene will also have one or more lights to make the shapes visible. And finally, there needs to be a camera to give the end user perspective on the screen. Now when animation comes into play, we can set up an infinite loop or some other trigger like the scroll bar to change the properties on these objects to animate them. Three.js makes this process very developer friendly, as you'll see throughout the video. But I would like to point out that it's not really a tool for modeling or drawing complex 3D shapes. For that, we have tools like Blender, and you can actually import your Blender models directly into Three.js to use them on the web. Now, before we jump into the code, make sure to like and subscribe, then open up vscode.js, and you can find the source code on GitHub or Fireship.io. First, we need to initialize a project that can handle dependencies and to do /app with a main.js and to serve CSS. You'll notice that I have a few images here. You can grab these images from the GitHub repo. However, I would encourage you to use your own images for this project. I'll be explaining the concepts in, however, I would the index.html file and add a canvas to the .js script and has an ID of background. From there, we'll go into our style sheet and give the canvas fixed positioning and pin it to the top left corner of the screen, which will allow it to serve as a background, and eventually we will overlay other HTML elements on top of it. From there, we'll go into our main.js file, and the first thing we'll do is import the Three.js library. To start things off, you'll always need three objects: a scene, a camera, and a renderer. The scene is like a container that holds all of your objects, cameras, and lights. Now, in order to look at things inside the scene, we need a camera. There are multiple different camera types in Three.js, but the most common one you'll come across is the perspective camera, which is designed to mimic what human eyeballs would see. The first argument is field of view, which is the amount of the world that's visible based on a full 360 degrees. The second argument is the aspect ratio, which is based off of the user's browser window, and we can calculate it by dividing the window's inner width by the inner height. Then the last two arguments are for the view frustum to control which objects are visible relative to the camera itself. Since we have 0.01 and 1000 here, we can see pretty much everything from the camera lens. Now that we have a camera, we need a renderer to render out the actual graphics to the scene. The renderer needs to know which DOM element to use, which will be the canvas with an ID of background. Once instantiated, we can use the renderer to set the pixel ratio to the window device pixel ratio and also make it a full screen canvas by setting the renderer size to the window size. Now currently, our camera is positioned in the middle of the scene, so what I'll do next is move it along the Z-axis, and that'll give us a better perspective when we start adding shapes. Now the final thing we'll do is call the renderer's render method, passing it the scene and the camera as arguments. And if we open it up in the browser, we should just have a blank screen at this point, so the next thing we'll do is add an object to it. There are three basic steps when creating an object. First, you need a geometry or a set of vectors that define the object itself. Three.js has a bunch of built-in geometries like box, sphere, cone, cylinder, and so on. I'll go ahead and create a new torus geometry, which is like a big 3D ring, and so on. I'll go ahead and create a new torus geometry, which is like a big 3D ring. Now that we have a geometry, we need to define a material to give it color or some kind of texture. Think of a material as wrapping paper for a geometry. There are many different kind of materials built into Three.js for different uses that will give you different results. And you can even write your own custom shaders with WebGL to use as a material, but that's beyond the scope of this video. Now, most materials rely on a light source to bounce off of them, but in this case, we'll use a basic material which requires no light source. It has a bunch of parameters for customization, like a color, and we'll also set wireframe to true to get a better look at its actual geometry. The third step is to create a mesh by combining the geometry with the material, and that's the actual thing that we want to add to the scene, which we do by calling scene.add. Now, to actually see it, we need to re-render the screen by calling the same render method again. You don't want to have to call the render method over and over again in your code, so a better approach here is to set up a recursive function that gives us an infinite loop that calls the render method automatically. We have a function named animate that calls request animation frame in the browser, which is a mechanism that tells the browser that you want to perform an animation. Now, whenever the browser repaints the screen, it will call your render method to update the UI. You can think of this as a game loop if you've ever done game development. Go ahead and call the animate function, then open up the browser, and you should see the torus shape. Currently, the torus is not doing anything, so let's go back into our animation loop and change that. Every shape that we create has different properties like rotation, position, and scale. And if we change its properties inside the loop, the shape will animate. In this case, we'll update the rotation along the x-axis by 0.01 for every animation frame, and we'll do the same thing for the y and z-axis as well. Back in the browser, you should now see the torus animated in an infinite loop. So that's pretty cool, but now I want to introduce the concept of lighting because that's what makes your 3D objects really come to life. Going back to our material object, we'll change it from mesh basic material to mesh standard material, which is a material that will react to light bouncing off of it. Let's also remove the wireframe property, then go back to the browser, and you'll notice that we have a black screen again. That's because there's nothing lighting this object up. There are many different types of lighting to choose from in Three.js, but an easy one to get started with is a point light, which emits light in all directions as if you added a light bulb to the scene. We'll go ahead and instantiate a new point light with a color of white. And by the way, if you're wondering what this 0x is, that is a hexadecimal literal. Whenever you write 0x in JavaScript and most other programming languages, it means you're working with a hexadecimal value instead of a regular number type. That's just a random good thing to know, but now back to our light, we'll go ahead and position it to move it away from the center, setting its x, y, and z values to 5. Make sure to add it to the scene like any other object, then let's check it out in the browser to 5. Make sure to add it to the scene like any other object, then let's check it out in the browser. The light is actually positioned inside of the torus, so it lights up the inside part of the ring. If we go back to our code and update the values to 20, it moves the light farther away and lights up a larger area of the ring. That's cool when you want to focus on a specific point inside part of the ring. If we go back to our code and update the values to 20, it moves the light farther away and lights up a larger area of the ring. That's cool when you want to focus on a specific point, but in some cases you might want lighting across the entire scene, in which case you can instantiate an ambient light. An ambient light is more like a floodlight in the room and will light up everything in the scene equally. Notice how we can see the entire shape of the ring at this point. Now, working with lights and shapes can be very confusing, but luckily Three.js has a couple of helpers that can make our life much easier. The first one is the light helper, which will show us the position of a point light. Instantiate the helper, then pass the point light as an argument and add it to the scene. Of a point light. Instantiate the helper, then pass the point light as an argument and add it to the scene. Then notice how that added a little wireframe that shows the position and direction of the light source. Another thing that's very helpful is the grid helper, which draws a two-dimensional grid along the scene. When we add a grid helper to the scene and then try to view it in the browser, you'll notice that we just get a little gray line here. That's because our current perspective is perfectly level with the grid. We can easily make the scene more interactive by adding orbit controls to it, which will allow us to move around the scene using our mouse. To do that, we'll first need to import the orbit controls class from the Three.js examples namespace. Once that's done, we can then instantiate the orbit controls class and pass it the camera and the renderer DOM element as arguments. What this will do is listen to DOM events on the mouse and update the camera position accordingly. We then need to call controls.update in the animation loop to make sure that the changes are reflected in the UI. At this point, you should be able to go into the browser and pan around with your mouse to see the full nature of the grid. Now that we have some helpers in place, I want to show you how you can use Three.js math helpers to randomly generate a go into the browser, update the camera position accordingly. We then need to call controls.update in the animation loop to make sure that the changes are reflected in the UI. At this point, you should be able to go into the browser and pan around with your mouse to see the full nature of the grid. Now that we have some helpers in place, I want to show you how you can use Three.js math helpers to randomly generate a large number of objects in the scene. In this case, we'll populate outer space with a bunch of randomly generated stars. To handle that, we'll create a function called addStar. Inside the function, we'll start by instantiating a sphere geometry where each sphere has a radius of 0.25. We'll then create a standard material and join them together as a mesh. That's easy enough, but the tricky part here is how do we randomly position these stars throughout the scene? What we need to do is randomly generate an X, Y, and Z position value for each star. We can do that by filling an array with 3 values, then we'll map each value to the Three.js random float spread function, which is just a helper function that randomly generates a number between negative and positive 100. We can then take those random numbers and set the position of the star, and finally add it to the scene. Now it's just a matter of deciding how many stars we want to add to the scene. For that, I'll create an array of 200 values, then for each value, call the addStar function. Back in the browser, our scene should be populated with 200 randomly positioned stars. And that looks pretty cool, but we could make this even better by adding a background to outer space. In many cases, you'll need to load images and textures into your scene. In this example, we'll load a simple JPEG image using the Three.js texture loader. It's worth noting that you can also pass a callback function here to be notified when the image is done loading. That's useful if you want to show a loading bar if your scene relies on a lot of static assets. In any case, we can set the image as the scene background by simply updating that property. And now the landscape for our scene is starting to look much more interesting. We can also add textures to individual materials, which is a big complex topic known as texture mapping. Basically, texture mapping is the process of taking 2-dimensional pixels and mapping them to a 3-dimensional geometry. To demonstrate a texture map, I'll go ahead and use the texture loader to load another image, then create a mesh that contains a box geometry and a basic material. The only interesting thing here is that we'll define the map property on the material as the texture. Let's go ahead and add that object to the scene, and now when we open the browser, we have a 3D cube with the image mapped to all 6 sides of it. That's pretty simple, but we can also combine multiple maps to create more interesting objects like we'll do for our moon. Let's create a new mesh named Moon that has a sphere with a radius of 3 and a mesh standard material. Now, just like the previous example, we'll load a texture of the moon JPEG and add that as the map property. That'll take the image and wrap it around the sphere. But another cool thing we can do here is give it the appearance of having some depth by adding a render and a mesh
on three radius
standard material. Now, just like the previous example, we'll load a texture of the moon JPEG and add that as the map property. That'll take the image and wrap it around the sphere. But another cool thing we can do here is give it the appearance of having some depth by adding a normal map to it. As you can see here, I have this purple image, which will create the appearance of dents and bumps and allow light to bounce off of them to create an appearance of an object that's not perfectly uniform. A normal map can make an object feel much more realistic with very little effort. Notice how the surface of the moon is no longer smooth, creating the illusion of craters and mountains. At this point, we have an animated scene, but I want to also show you how to animate it when the user scrolls. But before we can do that, we first need to add some markup to the page. In the index.html file, I'm adding a bunch of markup for the header and main content of the web page. The important point here is that the content takes up a lot of vertical space, allowing the main body of the website to be scrolled. You'll also want to make sure that the root parent element has a position of absolute. In my case, that's the main element, so make sure that's updated in your CSS. Now, back in the JavaScript, I'm going to first reposition the moon to be further down the z-axis because that's the direction that we'll be scrolling in. And it's worth noting that when working with many properties in Three.js, you can either assign them using the equal sign, or you can use a setter function like setX in this case. They both do the same thing, so it's just a matter of preference. From there, let's define a function called moveCamera, and then assign that function as the event handler for the document body on scroll event. That will fire this function every time the user scrolls. Now, inside the function body, the first thing we need to do is calculate where the user is currently scrolled to. One way to do that is to call the document body getBoundingClientRect function. That will give us the dimensions of the viewport, and the top property will show us exactly how far
const document body get bounding client react.
at the function body. The first thing we need to do is calculate where the user is currently scrolled to. One way to do that is to call the document body getBoundingClientRect function. That will give us the dimensions of the viewport, and the top property will show us exactly how far we are from the top of the web page. From there, we can start changing properties on our 3D objects whenever this function is called. We'll go ahead and rotate the moon and also the avatar, but the most important thing here is changing the position of the actual camera itself. The top value will always be negative, so I'm going to multiply it by a negative number. You'll likely want to play around with these numbers to get the animation you're going for. Now, the final thing I want to show you is how I use CSS Grid to make this layout really easy to build. I'm not going to go through every line of CSS, but I'll just show you the important things here. If we go to the main element, which is the main parent in the HTML, you'll notice that I have it set as display grid. Then I have grid template columns to repeat 12 columns at one fractional unit. Basically, that gives us 12 equally sized columns on which we can position all of the children. Now if we go down to a child element, like a section, we can add the grid column property and set it to start at the second column and end at the 8th column. Or in the header, we can start at the second column and then have it span across 5 columns. The bottom line here is that it's very easy to position DOM elements to align with the 3D stuff going on in the background. I'm going to go ahead and wrap things up there. If this video helped you, please like, subscribe, and share, and consider becoming a pro member at Fireship.io to support the channel and get even more content. Thanks for watching, and I will see
Imagine a world where creating stunning 3D animations is as easy as describing your vision. Introducing Say Motion by Deep Motion.
If you want to start creating 3D content on your web pages and you don't know how or where to begin, you're on the right place. Because in this tutorial I'll help you to get a good grasp of the fundamental parts of the widely known 3D library 3JS. This is by far the most downloaded 3D library, as it is commonly used by almost to watch the 3G package file command to use a more stable webpack. That said, now let's talk about placing elements. Now back to cameras. As I said, there are two types of them. The first type is referred to as perspective camera. It is basically the same as real-life cameras. To create a perspective camera in 3JS we need 4 values. The first one is the vertical field of view. It is the maximum angle of what can be seen through the lens of the camera. The second value is the aspect ratio. This one represents the proportion of the width and height of the image captured by the camera, and it is usually calculated by dividing the canvas width by the canvas height. The near and far clipping planes, these two represent the bounds of what can be seen and thus rendered. Anything in the scene that has a position closer to the camera than the near clipping plane won't be rendered. In addition to that, anything farther than the far clipping plane won't be rendered. The second type of cameras is the orthographic camera. An orthographic camera is used to render 2D scenes because depth doesn't count in this case. I'll make a comparison between the two types of cameras in just a second, but let's continue with the components of an orthographic camera. An orthographic camera is composed of 6 values. The first 4 are the left, right, top and bottom edges or limits of what can a camera picture out of the scene, and the last 2 are the near and far clipping planes, which I've already talked about. Here is an example to better understand the difference between a perspective and an orthographic camera. Notice in the case of the perspective camera, the size of the ball changes depending on how far the ball is from the camera. The closer the ball is to the camera, the bigger it looks, and vice versa. On the other hand, the ball maintains because depth doesn't matter in this. Now back to the code. Let's create our scene, and then the camera by representing going respectively from anything we talked about earlier into the scene.
Okay. I have heard this. Mate, let's check it out.
And this is it for this tutorial. I hope I succeeded. Right now the canvas in its current state is not responsive. As you see, resizing the window doesn't affect its size in any way. Another problem is that when I refresh the page, the canvas stays in that initial size, so if I close the inspector mode, you see that the canvas is still taking only 2/3 of the window and resizing doesn't do anything. To fix that, we need to add an event listener to catch any resize attempt on the window. Then within the callback function we need to update the aspect property of the camera, and make sure to call this method update projection matrix every time you update any property of the camera. We are calling it here because we are updating the value of the aspect every time.
You know, if you practice speaking in English for 20-25 minutes every day, you can really improve your fluency and confidence. Yes, it's absolutely true.
In this video, we are going to discover how to introduce HTML elements to the scene, like these labels on top of the checkpoints in the car. The idea behind this feature is to create sort of a layer or a container on top of the scene. Hey, in this video I'm going to show you how to take advantage of a model bones to create this mouse movement animation. The idea is simple. We are going to create an invisible object that follows the cursor and will make sure the
Physics for the wave with Canon. Okay, physics for the wave. Say this.
Hey, in this tutorial we are going to learn what is Canon.js and how to create a basic setup that can evolve into a big project like a browser game, for instance. That said, you're required to have a basic knowledge of 3GS to follow along, so if you're not familiar with the library, make sure to watch the 3-Volt Physics. It is a physics engine that is made to be paired with other libraries and objects.
What the heck is that?
I see you're interested in learning about Postgres. Why not learn from me, Dr. Chuck? I'm a professor at the University of Michigan.
To be The first thing we need to do is to create the projects folder in its package file. Then we are going to install a bundler. Using a bundler is not mandatory, but I highly suggest you to do so because it makes the project's organization way cleaner and easier to acquire a vendor like Webpack. That said, to install Parcel 2, you can either do it only for this project by typing the following command: npm install parcel-save-dev, or install it globally to be able to use it in any other project without having to install it another time by typing this command instead: npm install parcel-g. The installation will take some time, so let's do other things in the meantime. First, let's create a source folder which will contain the app development assets like the images, HTML, JavaScript, and 3D files. Something important to keep in mind is that we need to use
बोल लेते हैं। चल दिया क्या मतलब? हाँ क्या बोला? हाँ भाई बड़ा चल दिया क्या तू लोग? अरे भाई बोले बड़ा चल दिया क्या तू लोग? अरे उठा के रखा।
JavaScript and 3D files. Let's do into dev another time. Instead, npm to use the type attribute. and set its value to module. If we know we are going to do that, I'm adding it here. If you chose to use the version 1. Now that our project file install 3, that done, let's type some code. Install it globally. But first, HTML to use statement in the to create of the data aspect. We need let's create files. Use the as a having said as arguments. In here I want that space to take all over the page by using. Next thing we need to do is to inject that space we've just created, which is basically a canvas element, into the page. To make parcel, bundle the files and refresh the page automatically whenever we save any update in our code. Notice that a dist folder has been created the moment I pressed enter, and that folder will hold the distribution version of the app, including any asset that is located in the src folder and used in the code. To see the result of the few lines we typed, I'll push Ctrl plus left click on the URL ready, added by to 0.
I don't know how to code. Is Scalar School of Technology right for me? We get this question a lot. So let me share.
Works. First, when we talk about 3D in general, we are actually referring to a coordinate system composed of 3 axes. Furthermore, Or we get or by default lines we type. In this short video, we are going to learn how you build and host your Three.js project on GitHub Pages. So, if you're using Parcel, go to the package.json file and you have to make sure you delete this line.
In this course, Slobodan will teach you how to incorporate 3D models into your React websites and product pages. Slobodan is a senior full-stack developer and popular course.
The most impressive websites in the world all seem to follow a similar pattern. They use 3D animations to bring the application to life. For example, you cannot browse Bruno Simon's portfolio website. Instead, you can drive it. Yep, you heard that right. You navigate the website by driving a car that's interacting with the world by breaking the letters and crashing down walls. And let's look at Uni, which I think is a hippo, a smiling hippo that floats, changes colors, knocks people in the air, and then flies into the outer space with other hippos? I mean, you cannot make this up. This may look impossible, but in this video, you'll learn how to create your own 3D developer portfolio in React using Three.js. By the Three.js. But you might be shocked. Lighting completely new to Three.js. They're fully customized, modern, fully responsive design. Completely new to Three.js. With modern, fully responsive design, captivating 3D models that are fully customizable, smooth and seamless animations providing a buttery feel to the user interactions, the ability to send emails through the website, and much more. This is the best Three.js developer portfolio that you can currently find on YouTube. Alongside building your own 3D web development portfolio, you'll also learn how to use Three.js, a React 3 React, Framer Motion, animations, utility first CSS styling framework, Framer Motion, the most popular library used to bring your React website to life with animations. You'll also learn how to load, create, and customize stunning 3D models and geometries with various lights, as well as understand the 3D world with camera and positioning in the space. Make your code reusable and scalable using higher order components and other industry standard. This video reaches 20,000. The free resources section to the now on alongside the and front-end, back-end this into your own developer portfolio. Allow me to give you a quick demo of everything you will build. First, we have a wonderful hero section with a title and a subtext. Then we have this wonderful looking 3D model that you can move around. We can scroll to the next section that allows us to see the introduction of who you are and what you do. After that, we can see a great work experience section where we can see where you worked and what did you do at those specific companies. After that, we have some bowls right here that showcase the technology that you're passionate about and the technologies you know how to develop projects in. After that, we have the projects themselves. In this specific case, we're showcasing the projects from the JSM Masterclass experience. This person is definitely gonna get hired. After that, we can see the testimonials. What do other people have to say about you? Portfolio with a great 3D background and a contact section with a moving 3D model. What more can you expect? And these have been all of the sections of our great 3D, Framer Motion, React, 3JS, 3JS Fiber portfolio website that you will create in this single video with my help. Hopefully you're excited. Before we start building out our project, let's first get the hosting and the domain name for our new site, your portfolio, or any website you'll create in the future. And a free email. Decided to give you an even bigger discount. You can find the link and a unique mastery, all caps. Depending on what you prefer. In this case, I'm going to proceed with one of the existing domains that I already have. That means that we are ready to get started with the development. We're going to start by creating the structure and then app.jsx. Inside of here, we need to import all of the components we've just created. So let's get started by importing the browser router coming from react-router-dom. We're going to use for routing. We can then import all of our components by saying import application by going to source and then app.started with the development. We're going to start by creating the structure or the layout or the skeleton of our application by going to source and then app.jsx. Inside of here, we need to import all of the components we've just created. So let's get started by importing the browser router coming from react-router hero navbar tech works as well as stars canvas. This is all coming from /components. And now we can focus on creating the layout. We're first going to wrap everything in a browser router div. And that div is going to have and bg-prime this div as name equal to bg-hero-pattern self-closing navbar. You should be able to see a black background with just the navbar and hero components, which are essentially just p tags. With that said, we can now go below this inner div right here, and we can reference all of our components one by one. Each one of these components is actually a section. So first we're going to have the about section, z-0. We need
With Google Workspace, you can get any job done on your phone. From giving feedback to attending meetings.
Now we're going to fix this, but not only for this specific section. We're going to fix it for all of the sections we're going to create in the future. Because what you can notice is that they all have the same amount of space developing it. Our navbar is going to be, that's all that you actually need. So let's go back to our application and let's get started with the React as well as use. After that, we can import to navigate to coming from nav links. We can import the logo, the menu, and the close assets coming from /assets. And that's it. We are ready to get started. You can see we get an error, and that's because right here I named this style instead of styles. So let's simply rename it to styles if it's not styles for you already. Great. So inside of our navbar, let's start with the JSX tag. That nav, let's create a new div, and that div is going to have a class name equal to what I include in all of my YouTube videos. So if you haven't already, definitely make sure to. So going to have an alt tag that's equal to menu. UL right here is going to render different elements, but of course we have to change it just a bit. It's going to be, and we can add an extra space right here. But as you can see, it is tied. Section is going to have a class name equal to, it's going to be relative, w-full, h-screen, meaning text dash inside a square bracket. So to do that, we can create a auto flex, flex dash row, items dash start, and gap dash 5. And finally, within that, we can create a new div that's going to have a class name equal to flex, flex dash call, justify dash center, items dash center, and mt5 for margin top. Inside of there, we can render this circle and this line right here. So to do that, we can create a self-closing div that's going to have a class name equal to w-5, h-5, rounded-full, and bg-hash 915 EFF. If we save that, we should be able to see that circle right here. Let's pull our browser a bit to the right. And now we can create that line by creating another self-closing div with a class name equal to w-1 on small devices h-80, usually h-40, and that's going to be violet-gradient. There we go. So now we have the line as well, and we are ready to create our text. So that's going to be below this div containing these two divs. Below, we can create another div that's going to have an h1. h1 is going to say, hi, I'm Adrian. Name to this row. Create a new dynamic of who you are, vision, and I'm going to add a break tag, a self-closing break tag, that's going to be there on small devices. So class name on small devices block, state. After that, we also need to import something known as a canvas. And that's coming from add react-3/fiber. Canvas AI has been taking up presented a year ago, a vision of transporting humans into a 3D space. Today, I prepared something special for you. Not only will we dive into the metaverse, but we'll also fuse it with the power of artificial intelligence. The ring you want, this jewelry website that allows you to customize and create the ring you want by customizing your own 3D diamond color, as well as the ring color and the entire look and feel of the ring. Likewise, Car Visualizer allows you to look at different, incredibly detailed car models and change their color as well. Finally, the Showroom application allows you to customize your own living room in 3D. You can move around to get a feel for the space and then click on elements to customize their color and material, such as reflect incorporated with their version of the globe, where you can move it around and see where the websites are deployed. And Amazon with their 3D product feature own by the end related to camera shocked. I'll assume a lot of things from React. These are going to be suspense, use effect, and use state. After that, we also need to import something known as a canvas. And that
डॉलर मांगो नी नाम सदा चलदा Tem combination. डॉलर मांगो नी नाम सदा चढ़दा ऑलराइट दिक्कत कड़ी हो रही है ओके 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 if I wanna import the navbar by structure, वो थोड़ा सा लाओ क्यों नहीं हो रहा ये So that is the first example we are importing from the components folder, and in the second example we are importing the from the directly. Okay, so also make sure that file structure correct and workspace file structure. If you want to import neighbor component by destructuring, you can do like this. Assume you have default export in your neighbor.js file like this. Okay, and you have named export in your neighbor.js. And this I did export default. So yeah, export default. What is not that. Not that. Not that. Set. Set, yeah. Set. Set. Sala. अरे वहाँ से जा ही नहीं रहा क्या बात है सब तरीके What the heck is this code? Wow, it is working now. It is working now. Oh, wait, now what is the problem? If I am using T structure with T, import never fallen because it is trying to import that component to a specific file. Specific file. Okay. I'm trying to import many files from components at a time. I'm trying to import many files to have capture. यही तो मैं कर रहा हूँ बट हो क्यों नहीं रहा है पैरेलल फाइल let's see your files index for CSS checks. Inside the component folder, inside the component folder which shows multiple components. This ये वैसे क्या करता हूँ utils अच्छा 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 ये क्या चलो समझ गया मैं समझ गया सपोर्ट भी तो करना पड़ेगा ना भाई Very good. Next. Map bar, map bar, map bar. Here, link this. Navbar class name equal to dollars padding x. Flex items under. Three by five. Fixed top 0. Fixed top 0. Set 20. Set 20. 20. Tipper class, tipper class, double class.